All right, so what I wanted to do now is I want to talk a little bit about z-scores and maybe point you in a direction in terms of understanding z-scores. So, what you've done already is you actually watched or you've read about z-scores, maybe even done some of the homework on it. And so now I want to talk a little bit about unusual scores and basically calculating z-scores and what they mean. So this is meant to be kind of like an additional video to go along with that and to help you study for your exam. So, let's say, for example, I have this problem. Suppose that I wanted to know if a certain basketball game by Kevin Durant was particularly good. Okay, so let's say Durant, who's a great player, has a scoring average of 24.5 points with a standard deviation of 7 points. Okay, so let's say that's the career average. Now, what I want to do is I want some way to talk about these as being very, very good, because for Kevin Durant, a scoring game of 30 points might not actually be all that great. It might be pretty good. It's a good game. 30 points is always great, but it may not be fantastic. On the other hand, if you'll talk about somebody else, and we'll get to one of a different player, that might be really, really good. That might be like a career all-time high. So, how do we determine whether or not something's really good, right, or not, depending upon the distribution that I'm looking at? And that's where the z-score comes in. So, the larger a z-score is, okay, or the farther the z-score is from 0, the rarer it is. So supposedly that's actually how these things work, right? So z-scores that in absolute value are really large are going to actually be pretty rare, and so we could say, like, say for example, if we get a Kevin Durant one that has a high z-score, then we're going to say he did really, really well there, okay? So like, let's take for example, we'll look at, and we got, say, we want to know, what if he scored 33 points, okay? So this is x. X is going to equal 33 points. And so my z-score is going to equal 33 minus 24.5, okay, divided by 7. So that's how I calculate my z-score. And so let's go in here. My calculator in there. 33 minus 24.5 divided by 7. Okay. And so that's 1.214. Okay. 1.214, right? And so what that tells me is that this score, 33 points, is 1.214 standard deviations away from the mean. So if I imagine, and this is actually exactly how this works, my mean, right, is at 0. Okay, so in this case, that's a score of 24.5 points. And what I'm going to look at is I'm going to go one standard deviation over, and then a quarter, or 0.214, a little bit less than a quarter, so 214, and then this here is 33 points. Okay, that's equivalent of z equals 1.214. What if, say, for example, Kevin is not having the greatest game in the entire world, and he scores less points than that? Let's say, for example, now he goes out and he only scores 20 points. Is that such a bad score, right? Okay, it's below his average. And so we end up with 20 minus 24.5, and we're going to divide that by 7, okay, because that's how I find my z-score. And that's going to be 20 minus 24.5, okay, divided by 7, and that equals negative 0.643. And so if I look at this, this is, not a little bit more than half a standard deviation away. So here's 20, okay? And that's z equals negative 0.643. And the reason why it's negative is because it's less than the mean, right? Okay, so the negative scores, the negative is less than the mean, less than x bar, and the positive ones are going to be more than our x bar, or mu, depending upon which one we're looking at. Okay? So we're like, okay, well, Kevin, I mean, like, what does constitute an unusually good score? So what we need some way to talk about what makes an unusually good score, and that's actually where the standard deviation rule comes in. So a z-score of 2 or more, or negative 2 or less, is considered unusual. Okay? So if I look back up here, right, I've got this 1.24 here, one for 33. I need to go a little bit further out to some value out here that has a z-score of equal to 2. And then in the negative direction, I've got to go actually quite a bit further out, and I need a z-score of -2 to determine something that's an unusually low basketball score. Okay? So there's my z of -2. Okay? So how am I going to figure that out? Well, I can either go in and I can do some algebra, or I can kind of just break these things apart and figure out what it is. So I know it to be 2 above the mean or 2 below the mean. So I'm going to start out at the mean, okay? So I'm going to have 24.5 plus, okay, 2 times 7. So that's 2 standard deviations above the mean, okay? That's going to be 24.5 plus 14, and that equals 38.5. There we go. So if he scores 38.5 points or more, that's going to be unusual. Now, what if he scores, what about a low score? So now this is going to be 24.5 minus 2 times 7. So that equals 24.5 minus 14, and that's 10.5. So if he scores below 10.5 points, okay, negative 10.5, then what that tells me is that that's an unusually low basketball score. So anything that's in between here, so let's kind of imagine that we've got all this stuff in here, right? In between the -2 and the 2, we're going to call that usual. And anything that's outside of those 2 standard deviations is going to be considered unusual. Another way to talk about an unusual is to talk about it as an outlier. So there's my unusual and my outliers. Okay? Now, this is for Kevin Durant. Now, let's take a different player. Let's take one of our all-time favorite Lakers, Adam Morrison, who, well, he should have been better. What can he do? The guy just wasn't fast enough to play in the NBA. That's all there was to it. Couldn't jump. A lot of reasons, I guess. So, let's say we take Adam Morrison. Now, Adam Morrison doesn't score like Kevin Durant does. He's a different kind of player. So let's look at Adam Morrison. Let's say, for example, we've got him, and what we know about him is that he has a lifetime scoring average of 7.3 points with a standard deviation of 3.9 points. Okay? So now, a score of 38 points by Adam Morrison is going to be really, 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 really good, because it's just totally unexpected. His average is 7.3. Okay? So we need to figure out what constitutes really good for him. So, like, let's say, for example, we say, okay, well, I wonder if he scored 15 points. Would that be considered unusually good? So let's take a z-score, x equals 15. That's 15 minus 7.3 divided by 3.9. Okay? So now, that's because this is a different distribution, his point scoring. We've got a different mean, different standard deviation. We divide that by 3.9. And that's 1.974. Now, that is not 2 or bigger. So, it's not unusual. Hey. So what you can expect is that it's not incredibly common, but it does happen. It's not really, really rare. It's close. It's close to unusual because it's close to 2, but it's not unusual because it's not 2, right? So let's figure out what unusual would be. So I'm going to take this. I'm going to have 7.3 here, okay? And what I need to do is I need to go 2 standard deviations down. So 2 times 3.9, okay? That's what 2 times 3.9, that equals 7.8. And so it turns out that means that that's going to be negative 0.5 right down there, okay? So, and then what about in the higher direction? We're going to 2 above it, right? Okay, so that's going to be 7.3 plus 7.8. Okay, and so that's going to equal 15.1 points. So anything more than 15.1 points is considered unusual, and anything less than negative 0.5 is considered unusual. So really, in this case, because we can't have negative points, no matter what you think about the scores there, there's unusual, right? It's going to be above 15.1 points. Anything in between those 2 standard deviations, in between a z-score of -2 and 2, that's going to be considered usual. Okay? So, we have two ways of thinking about this. One is we can think about it from the perspective of, does a score actually constitute something that's unusual? If we find the z-score and find that it's either less than -2 or greater than 2, then it's unusual. Or we can find the boundaries. In this case, what do? We take the mean and we add 2 standard deviations to it and subtract 2 standard deviations from it. Okay? Not 2, we don't subtract 2, we subtract 2 standard deviations, right? Which is something that we're given inside of each one of our problem scenarios. Okay? So how do we define an outlier using the standard deviation? It's either -2 or 2 or more standard deviations away from the mean. And this is how we go about finding something like that. This completes